When we interact with everyday surfaces, touch, tactile, and haptic feedback are very important for interaction. When interacting with a digital table, tactile feedback is generally static, unchanging, where the texture of a table does not reflect what the person is doing or the task at hand. We created the Haptic Tabletop puck as a vehicle to explore tactile and haptic interaction on tabletops. The primary component of the puck is a vertical rod that moves up and down. It is designed to put your finger on. It can move to and hold static heights. It can maintain low-frequency oscillations, and it can also produce medium-frequency vibrations. The puck also senses the pressure that the person applies to the rod, and uses the measurements to form a force feedback loop, for example, by responding to touch by lowering the rod, and lifting when no pressure is applied. This response can range from soft, to firm, to rigid, or can be non-linear, such as simulating a breaking point. The puck also has a brake on the bottom that can be engaged to increase surface friction and resistance to movement. The puck is designed for a person to hold and move around the table while the position is tracked in real time. The properties of the puck can be mapped to elements of the tabletop system. For example, rod oscillations can be used to represent water waves or other related properties, or the brake can be used to make the puck resist leaving a region. The force feedback can model various materials that a person can interact with, such as firm wood, loose gravel, soft moss, or squishy styrofoam. The puck can enable a person to explore the texture and materials of a surface, portraying the underlying bumps, textures, and grooves. Here the puck can be used to follow a groove or ridge. This contrasts with the generally unchanging texture of digital tabletops. The puck's capabilities can be combined. This X-ray density can be portrayed by height, with denser regions being higher, or through force feedback, where regions such as bone are more rigid than softer tissues. This map represents relief as rod height, and varying land types as different materials. Rod oscillation speed is used to represent ocean temperature. Rather than obstructing this painting with icons or text, information points produce a bump that a person can press on to get information at a given location. The puck can also be used to explore regions of a painting that have been painted over. When a bump is felt, the rod can be pressed to see below the surface. Pressing harder looks deeper. A person can paint on the surface by pressing on the puck. The puck resists painting over borders, but can be forced to do so by pressing harder. The puck can be used to feel the height of button widgets. A button is pressed through the rod, which lowers to reflect the button's state. This also allows for important buttons to be harder to press. For floor planning, items can be picked up and moved around. Objects resist leaving a room and require the person to push harder to pull it out. The puck provides interesting possibilities when two distant people are interacting on the same space, such as awareness of the other's activities through ripple bumps. The puck can also be used to mitigate conflicts, where rod pressure can be used to negotiate ownership. People can press harder to argue for the object, or release the rod to let the object go. The puck is a wooden box with embedded servo motors that respond to commands from a PC. The software system is built around layers to represent the different properties, such as a height relief map, materials, and oscillations. Thank you for watching our video.